welcome, a warm welcome this time from Aachen to a new episode of Beyond Cost. My name is Jakob Etzel. I'm the Vice President Customer Success at Z and the host of today's episode. And it's a great pleasure for me to welcome Professor Dr. Jana Backes into this episode. And we will speak today about the sustainability, how sustainability is connected with product cost in a manufacturing setting. We will also speak about how you and your students are applying artificial intelligence when it comes to estimating sustainability indicators in a production scenario. But Professor Backes, I think it's actually best if you take the floor and introduce yourself.
Yeah, thank you very much, Jakob. Great to be here, and thanks for the invitation. My name is Jana Backes. As said, I just got the chance to launch a new chair here at RWTH Aachen University called Sustainability and Foresight, so in short, SAF. It's a junior professorship focusing on safety, security, sustainability, and foresight research. So a bunch of things. From my background, I'm environmental engineer, did my PhD here in Aachen and focused on life cycle sustainability assessment. So the assessment of all three dimensions of sustainability. And if I'm not here and working, then I'm a mom of two young kids, really enjoying both sides of life, family life and being a mom. And on the other side, being a young scientist, really loving her position.
That's great. Very impressive at that young age, already a professorship. And actually, as you said, your chair, usually that would be three different chairs. Maybe one for sustainability, one for foresight studies, one for the security aspect. So very impressive of how you try to combine all of this in your teaching and in your academic research as well. Jana, you actually started your career in the industry.
Mm-hmm.
You did a dual degree at BASF in the chemical industry. And then you went to Munich and studied full-time and did your PhD here in Aachen at the very prestigious institution where you have now your professorship. What held your path together? What got you where you are now?
Yeah, I think the idea or the interest in processes in general, and then especially, of course, industrial processes. And back in school, I got the chance to participate in the youth science competition Jugend forscht, it's called, which brought me to the BASF, kind of accidentally, let's say, because there was the one of the competition parts, and I got to know BASF and was really impressed by that big company, all the processes behind and things like that. And then I decided that this might be interesting to start a career and work there. And I started with a business program and studied business administration, which also today still is quite helpful, also to connect sustainability with economic aspects, especially. And BASF also that time sent me for half a year to Chile. And I spent half a year in South America. And I think that, again, pushed a bit the idea of, or the interest in sustainability in general, focusing on resources, but also social sustainability, again, coupled with cost, because coming out of the industry. And that led me then to my master's program in Munich in sustainable resource management, which again is also part of all three dimensions of sustainability. So the environmental, the economic, and the social dimension, bringing all that together. And sustainability is a practical dimension. We need it in the industry and also, of course, somehow in our daily lives. And that then again brought me also back to BASF and then later onwards here to RWTH and focusing then on the assessment of sustainability. But all driven by this interest in processes.
Yes, and in recent podcast episodes, we always asked what brought people into product costing. And the answer that came most often is it happened by accident. So you kind of now said also by accident you got into your topic.
Yeah.
But when you now think back, last 15 years, when was the first moment that you realized sustainability will be the topic of your life? But also, when was the moment that you realized you will end up in academia and not in consulting, where you have been as well, by the way, or in the industry?
Yeah. I think that really might have been the time at Chile, where I came back to that, okay, resources are important, social sustainability is important, that things are interconnected. That time, I think it was clear that I won't continue further with just the business aspect, but adding up sustainability on that bachelor studies. And then, of course, the master's program in Munich forced that and supported it somehow. And during the master's program, I also got a gut feeling that teaching is important for me. Education is quite important, that a lot of things can be brought to younger colleagues with enthusiasm to also push the topics together, and that we can learn from each other, and things would be best if we do it together, whereof teaching is quite important. And that time probably was the time where I realized it might be academia, it might be the part of teaching, supporting younger colleagues, which then also brought me back after a year full-time working in industry to academia doing my PhD. And after the PhD, again, it was the time, will I stay or will I go to industry and push there forward? I think both is quite important. That's also what drives me to have a strong connect to industry, even though I'm in academia now, as it is a practical applicative topic.
And a university in Aachen has a good history of being connected with the industry.
And I personally also really like it because from the industry we get a lot of feedback, which is quite helpful for research, and doing research just out of university in that specific topic of sustainability assessment wouldn't make sense, in my opinion. For that, it's quite important. And a lot of that, as you said, also from the other partners being in the interviews, a lot of that happened by accident and with a gut feeling, and definitely also an intrinsic motivation and the fun having in specific topics, in teaching, in collaboration.
And now, speaking about the typical manager, executive in a manufacturing company, like the one that you have been working at or the ones that you have consulted, what do you think is a common misconception they have about emissions, sustainability, accounting?
Yeah, misconception is maybe a bit too big. I would say until a few years ago, sustainability was mainly connected to environmental or ecological aspects, which it is not. Nevertheless, I would say nowadays it's getting better and better, and especially the big companies, I would say, all think already in more dimensions than just the environmental one. But of course, it is easiest to connect it to, for example, a carbon footprint, because that's easily or more easygoing. Data is more available than, for example, for social aspects. The economic dimension is anyhow always in mind when we talk from the industrial perspective. So misconception maybe was that one-dimensional perspective, and maybe also still is existing regarding how many sustainability indicators are we focusing at and using for decision-making, for example. So in best case, it should not only be the carbon footprint, but more. But there is a lot of movement driven by diverse aspects, which is quite positive, I would say.
And if you think about your students, so right now you are lecturing a lecture series, I would say, that is an introduction into sustainability for engineers here at the University in Aachen. When you think about your students, they started 2 months ago in the lecture series.
Right.
What has been their main misconception, or what is their aha moment in your lecture?
Yeah, so the one thing I already said, that still the connection of sustainability is mainly driven by environmental and ecological aspects, and
so
maybe
the same,
also the same, and also still maybe having a bit in mind sustainability always needs to be green, let's say, kind of this. So that sustainability is way more than just ecological environmental parts. And on the other hand, also the aspect that I think we all should stay critical when we see numbers, because they say there is just one value telling the truth, which not necessarily needs to be the truth. So if we, for example, think of a carbon footprint, then I think it's quite important to really tackle that number question it, reconsider whether that could be or is plausible, how it was balanced, whether it makes sense or not. Or also, for example, when we talk about net zero, might that really be the case? And if so, how did people arrive at that number? Or shouldn't it be maybe a range instead of being one final value? And then students, or the main goal I have is that students start being critical regarding the topic sustainability, being driven from diverse perspectives, and also questioning whether one value is really telling the truth.
And when students leave your lecture series in June, end of
2-3 months. Yeah, end of July.
Will they have then done, as part of their homework, a product carbon footprint for a manufactured part, or yes?
Yeah, it will be one part.
Yes.
In best case, they are able to connect a lot of, let's say, sustainability buzzwords. So from global political aspects down to, for example, a carbon footprint, resources and emissions. And we also have a seminar which is connected to the lecture, where they get 3 main tasks, a bit connected to the industry and also to, let's say, consultant perspectives. And one task there is also to calculate a product carbon footprint, but also from the other side, question whether that value is plausible, how it was calculated, how much options I do have if I know how to model to get this or that result.
So students will understand how to, let's say, fine-tune the PCF, but also, if they sit on the other side, how to validate it and reverse engineer which fine-tuning might have happened, which is really medias in res, directly bringing us into one of the main topics of today's podcast, and I would like to connect it now a bit with cost. So in a manufacturing process, emissions appear. It's part of producing something that I burn, for example, fuel, that I consume electricity, and already now the social cost of this environmental pollution is built to the companies, only partially, but it is happening. And the main instrument for that is, we all know that, the emission trading system of the European Union. And you have made some analysis where you can show that already now cost is passed along in the supply chain. If I am a procurement executive, if I'm the head of purchasing in a manufacturing company, how should I deal with that?
Yeah, in best case, start integrating it into the balances and consider it for the entire value chain. So when purchasing, then talking with the suppliers, whether they already accounted it in. And if so, maybe also directly how they accounted it in, with which value did they took the actual one, and also updating it. Then, of course, for any forecasting, including it into the forecasts, and especially also including it, for example, if you think of new technologies or whatever development might be there regarding new designs, included in the forecasting for new designs, also considering end of life.
Good point. So let's dive one step deeper into the topics that you right now touched. So you say forecasting. So obviously, as a head of procurement, I want to understand how much I will spend, how much money I will have to pay for the goods that I need to purchase next year for the company operations. But I also need to forecast maybe in 5 years. So what you say is that costs might increase due to changed emission prices, but also due to changed legislation, correct?
Yeah, and also I would say due to geopolitical aspects. And probably also economic aspects. To be honest, that's definitely not my main research area. And I would consider it or put it more into the areas of colleagues from the economic part or from politician areas, things like that. But there are a lot of aspects coming together in my research area when it comes to sustainability assessment. We have to consider it because it pays in there,
Yes.
be it in euro, dollar, whatever,
Yes.
but also, of course, in emissions. And we have to account that as well, especially when it comes to new designs, forecasting. So when we come again to that Foresight Research, for example, then it is important to have that in mind. But I would say we are not the right people to ask when it comes to what might be the value in euro for a ton of CO2 in 10 years.
But I might just call my head of strategy at work and ask the strategy department, give me a price with which I should calculate. But then the question is, okay, I have now the price, but on which input factor should I multiply it with? So how would you say should I approach making a baseline of my supply chain product carbon footprint? So if I am new as a head of purchasing in a manufacturing company and I realize my new workplace has no idea at all what is the product carbon footprint of all the purchased goods, what would be a good starting point? How can I get the first number, which I then can use to calculate some forecasts?
Yeah, I would say most important is to understand the processes and the manufacturing, which is behind. So, and of course, I would also say that almost every company might or probably has already all the data needed because they anyhow purchase goods. They know how they process. So they all have their scope 1, 2, 3 data in mind. They know what energy they purchase and so on and so forth. And I think it's quite important for everybody to understand that, let's say, flow chart. So you know how that product you want to have at the very end is processes, what resources you need for that. And then you can also draw the entire value chain.
Right.
In best case, you get down to the first supplier in the entire process, which is probably the hardest part. So that's also the main issue we have in sustainability assessment. It's about data. And often we, at a company, can get the data from the first supplier one step back, but maybe not the entire value chain downwards. And that's, for us, the biggest issue, but probably also for the companies, to understand the entire value chain. In parts, it then might be assumptions to be considered. In other parts, I think it's getting more and more important to be transparent with the value chain to understand the entire back tracing.
So you would say I would pick some of the most expensive goods within,
for example,
my spend, and then try to understand which energy sources like natural gas, electricity go in there, what are the main processes where they are consumed, and then obviously where they are located, in which geography. Okay.
Yeah, and whether they, for example, consider critical resources.
Raw materials. Yes.
Exactly. Yes. Yeah, things like that.
And you say critical resources, and you mentioned that just because of the product carbon footprint, or also because of other aspects of sustainability?
Also for other aspects. I mean, on the one hand, if you stay in that environmental area, then of course, due to emissions, a product carbon footprint, for example, so CO2 emissions, or CO2 equivalents, better said, but also, of course, resource criticality. So how much of a specific good can we still take out, or should we maybe better think of circularity aspects and then make use of a secondary life of a specific resource. And when we have that, of course, it is all again connected to costs, but also to a social dimension. So if we talk about mining in other countries of the world, how are, for example, working conditions, how's the entire supply chain from a mining where we get the real resource up to a final product we might see here.
You argue in your public appearance and in your papers that one should not reduce sustainability topics just to the product carbon footprint. Also, in your introductory words today, you said it's much more than that. But why you think is the industry still so much focused on the CO2 footprint?
Because it was mainly the important part being in media. And also being requested somehow. And on the other hand, because there the data availability is probably the best one existing. Just because it is focused since years already. I think most big companies already make use of software solutions, databases, and things like that, whereof the CO2 itself, but also all the other emissions paying into a carbon footprint are probably best measured and considered. And due to that, the data availability is best and most easy to assess. Maybe to add on that, also because reporting requires it. So also here, a carbon footprint is questioned by a sustainability reporting and also somehow by everybody outside asking for how sustainable are you, and then people connect with a carbon footprint, for example. And that's probably the reason why this is mainly focused on still, even though they know quite well about the other sustainability aspects.
But you would say it's fair that PCF got most attention in the beginning? Is this really the most pressing problem, and therefore it's good that it's being addressed first? Or you say actually some other topics that right now are more or less overlooked would have way higher importance and priority?
Yeah, I mean, why not? Years before we talked about ozone, which was quite important regarding sustainability aspects.
Fair
so
point.
This is, let's say,
it's solved.
Yeah, exactly. Or at least we are on the right track. And now it's global warming or climate change, however we want to call it. And here it's definitely clear that the CO2 equivalents are relevant regarding that aspect. And I think also in different countries of the world, we might experience even more than we already experienced it here in Germany, for example, that climate change is existing. So that indicator makes sense. But it could also be that if we make a turn and if we change it to a reduction, that in like 20 years, it's no more a product carbon footprint.
Right.
We have a different topic. And for example, also biodiversity as indicator is getting more and more important, and people pay more attention on that than it has been the years before.
So you say ozone took more than just 2 years, kind of get solved. It took a couple of decades.
Exactly.
But humankind showed that they can indeed solve sustainability problems.
Yeah.
We are focused on PCF now. And then interestingly, you mentioned biodiversity. And you are not the first one. I recently asked someone, am I missing out on a topic? What will be next? And biodiversity came up. So will it be the next big topic? Can manufacturing companies already expect that they need to write long biodiversity reports in the next 5 years?
Good question. To be honest, I don't know. But at least I would say there's more attention on it than it has been. So it might be easy to forecast that there might come more. And also from the sustainability assessment perspective, there is paid more attention on it. So maybe it's getting a second quite relevant indicator in the future besides the carbon footprint.
Is academic output globally increasing in the field of biodiversity? So
would say yes.
Yes.
Yeah, I myself haven't paid that much attention on it until now, but from colleagues in other institutes and universities, I get the information that this is increasing and coming more and more important. So yeah, maybe, I don't know, a sustainability reporting in future also would need that indicator to be reported.
Yes.
And CO2 is getting less. Let's see what happens in a few years. But definitely that topic is increasing.
Very interesting. I would now like to talk with you about the core of your research, because so far we rather touch neighboring topics, but the core of your research is methodology. So how exactly do I measure things? For example, the PCF. In one of your research papers, you made an example that a steel coil in the calculation can end up with very different numbers of what is the PCF of a steel coil. It can be up to 35% different. Yeah. What are the main reasons why the same physical piece of material in the PCF analysis ends up with so different numbers?
Yeah, I think we have to touch there a few different layers. So if we take it just, let's say, from the production perspective, then it depends a lot on what kind of resources did I take from where,
Yes.
which energy sources did I consider, and of course also in which country am I producing, and how does the production itself really happen. So that might be one layer, because we all know that if we, for example, include more scrap into a system, then emissions and also resources might be better than if I take only primary material. And for example, if you consider, let's say, green energy, might it be solar, wind energy, whatever, then of course also a carbon footprint decreases due to green energy. And if you, for example, produce in Norway, having, let's say, only green energy compared to other countries, then also here again, we have a benefit in the emissions.
I think that's the part very easily to understand for everyone with a technical engineering mind.
Yeah, and I would also say that production engineers in a steel company could explain it even better than I do. So I have a bit of understanding on the processes. And then when we come to the area where I'm mainly working into that assessment itself, and for example, if we stay with the product carbon footprint, then we talk about life cycle assessment, which is the methodology being used. And here there's a diversity of things which might lead to that range of different carbon footprints for example, a steel coil. I think it's important to understand that there is already an existing ISO norm since years existing, which guides everybody through the entire LCA process.
It's 14064 or something in the 14.
Exactly. The LCA itself is 14040 and 4040. And then for the product carbon footprint, it's 64 and 67. So there's guidance, and one should think that this is totally clear and we all can end up in one final value being the same. And there is where the truth is not fully there, because there is variation in the system, which from the scientific perspective is quite important and interesting. But for comparison reasons, and maybe also for everybody outside the LCA bubble, let's say, it's quite hard to understand why is a steel coil having that many different values, except having the knowledge, resources and energy, for example.
So let's assume I keep the material source fixed, I keep the energy source fixed, I keep the location fixed and the process fixed. And I need to make a PCF that in the end the validator will will assert that it's following the ISO norms. What can I change to get it a bit higher and to get it a bit lower?
If I dive then into the LCA, one of the main aspects is data. So am I using the primary data out of my fixed variables in the production, and am I taking the measured values? Then there's already a lot of solved. If I'm making use of secondary data out of databases, which in LCA is often done because primary data is missing, then we often make use of databases, open access, but also paid databases. There is data in the background which is not perfectly fitting to exactly that process I have. And I often also have a variety of potential processes I can select to model. And it might be that if you do an LCA, I do an LCA, we didn't talk about it, and we both found a process which said, I don't know, heating, for example, then each of us took a different one, even though both were named heating, and both brought different background knowledge and background data, and we came up with a slightly different value just for heating, which of course also changes the final carbon footprint of my steel coil.
So I can create a PCF that gets that is compliant with the ISO norm while using secondary data.
Exactly. And they're using a variety of secondary data, or maybe also primary data, bringing different data backgrounds, leading to a change in my final value.
Right.
That is one point. Another point which brings a diversity in that final value is the so-called impact assessment methodology. That means how individual emissions pay into, for example, a carbon footprint footprint or a CO2 equivalent, let's call it like this, because it's not only CO2, it's also, for example, methane.
So there are like how many? 16 greenhouse gases or a bit more or a bit less? Is actually that number fixed? What classifies as a greenhouse gas?
Yeah, for example, so which chemical components pay into the carbon footprint, for example, depends a bit on which methodology I choose.
So also that is not given.
Exactly. And then how much weight it is, for example, methane compared to a CO2. And that also varies a bit from methodology to methodology. And there is a variety of methodologies out there. In LCA, I would say in research, there is a tendency to 1 or 3 different methodologies which are often used. And also in industry, I would say the different sectors make use of more or less a specific assessment methodology. Nevertheless, it's not always the same. And with that, comparison is getting difficult, because if you use one methodology and I use another, then we definitely won't have the exact same value, even though we choose the same data, just because out of weighting.
So the question is, it primary or secondary data? And if secondary, which one I choose?
Exactly.
This is a factor of variation. Then the impact assessment, like which greenhouse gases are included and which not, and how they are put into equivalence. Any other lever that I have in the methodology?
Yeah, I could, in the so-called golden scope, which is the first part of an LCA, decide how do I draw my so-called system boundaries. So am I focusing, for example, from cradle to gate, so taking all the resource extraction, including transport, all the processes, manufacturing, which might be at my company, but also already at suppliers beforehand, into the process? Am I only, for example, considering gate to gate? So from then it only considers, for example, the production I have internally, mainly focusing on, for example, energy used to process. Am I already considering or also considering a use phase, for example? Am I already accounting an end-of-life option into the model, and so on and so forth? So also this, of course, shows a diversity of values ending up, because it's clear the broader we take the system boundaries, the higher the value probably will be, except we take the end of life in, and end of life might also come with recycling, for example, and then it might end up into a credit balancing out again. Could be an option.
Would that mean that if I'm producing something that emits some very exotic greenhouse gas, but this in a very strong amount, that I might then look at the 3-4 most commonly used LCA methods, and I would pick the one that weights this gas the least? Whereas if I'm more a standard manufacturing company where most of the problem is the carbon emission, I might rather pick another methodology.
Yeah,
you see, is that really happening? Are companies already, let's say, exploiting the variance of methodologies? Because for all of them, I can get in the end a certificate that says auditor said it's compliant to the ISO norm.
Yeah, exactly. Yeah, that would all be compliant to the ISO norm. Thank God it's not that worse, as you said. So the emitted chemical reactions, let's say, are not that diverse over the impact assessment. Nevertheless, the weighting is changing a bit. I would say this is probably not the biggest reason for a variety in the final carbon footprint, but it is counting in. Even more important is probably that data part. So the second phase of the LCA, when it comes to choosing data, for example, from databases. And then, of course, if I'm able, for example, to choose in a variety, if we stay with that heating aspect, to take a value which is lower than another one, and I could take it because it still, in the description, gives that information that it is doing that what I'm doing in my processes, and heating is heating, and I'm using an energy for that, but it has a lower emission for that process than another one. Of course, with that, I would be able to reduce my carbon footprint, and it is ISO compliant because there is no rule that says you have to always take the highest value and things like that. Nevertheless, I would also say, or I think it's important to say that according to the ISO norms, values get checked from reviewers externally. That is a must-do when using the data for any published aspect. And I also think or hope that all the LCA colleagues are quite critical in also focusing on which data was used and why did you choose that value and not another one. Could you please explain? And with that, I hope that the values are clearly explained, reasonable, and then it's also fine. Nevertheless, if I'm assessing, if I know quite well what to choose and that there is a variety, I'm able to choose in whatever direction. In best case, and what is, I would say, mainly done in research is that we consider the worst value having the most conservative example being used for a value. And with that, we more or less could say it probably won't be higher than that value because we took the worst number.
I mean, fair point. You are interested in the worst value in research, but as an industry player, I would rather go the other route, the other way. But very interesting. Going back to the example of the steel coil that we started this discussion. So for the steel coil, could it happen that the auditor that is validating my product carbon footprint says like the main energy, like the main precursor is electricity. Let's assume we are not going the blast furnace route, but the electric arc route. And I used the secondary data, like I used for a steel mill in China, just an, I don't know, International Energy Agency value 2 years old, average Asia electricity footprint. Could it be that the validating agency says like, we reject that? You need to improve, you need to, I don't know, call your utility company and provide a written document what is actually the emissions.
Could happen, and I also hope that this happens, to be honest. For example, the ISO norm already states that the data should be timely valid, so no like old data, that it should be geographically fitting. So for example, if we are producing steel here in Europe or in Germany, then the Asian value hopefully directly would be rejected with the reason.
I see.
How can you take Asian electricity values into a German production, for example? Doesn't make sense.
And connecting it again with cost. So from a manufacturing company perspective, I will take this value and then multiply it with cost, for example, to make a forecast how much in my supply chain the cost for the emission trading system in Europe or an equivalent instrument abroad will increase. And then in this forecast, I can take a more conservative value to be on the safe side, or in the methodology, I can take a more favorable one in the sense of I get the lower increase. But and here comes my question: is actually the European Union, when they calculate how much emission certificates I need to render, are they giving a clear methodological guideline, or is the European Union saying for a steel mill, just calculate something that is certified under this ISO norm, and that's good enough, and based on that you hand over the certificates?
To be honest, I would need to recheck that in detail. But there are already existing approaches, like for example the EPD, Environmental Product Declaration, which is a bit more structured and detailed than the ISO norm is. It is fully based on the ISO norm, but it already says we take these indicators and they have to be weighted behind, so in the so-called inventory phase, when it comes about which chemical reactions are weighted regarding the CO2, then this is already fixed. Or for example, also PEF, Product Environmental Footprint, they guide already in a more standardized and comparable way than if you just would leave it on the ISO norm. Because there is the freedom. And if I'm not mistaken, then I think there is a guidance or a requirement from ETS saying this and that methodology should be used. But I'm not sure how strict it is that it needs to be used.
Yeah. No, but this is very interesting what you say without now checking the details. But you say, yes, there is a movement of political actors to not just accept the ISO norm, which is a little bit, or maybe even a lot, allows for a lot of variance, but already giving clearer guidelines.
Yeah.
But it might also mean that other political actors in Asia, in North America and South America and so on, might actually specify it in another way. And I'm again getting a variety of different norms.
Could be. Nevertheless, I think somehow we're currently here with the European Union front runner.
Okay.
And due to the fact that we also have CBAM, so the Carbon Border Adjustment Mechanism, which is that, let's say, external pricing coming into Europe, which is connected to the ETS, that somehow then also requires, let's say, the same rules.
Yes.
And with that, I would suggest that the not European countries might take over the rules from Europe as a front runner, because it is required here.
Right.
And with that, if they would come up with something different, it is hard for the entire supply chain to take it over, because it differs again. And then it's also hard to implement material resource products into the European context, because then comparison and also like the CO2 pricing might become even more complex.
So you say with the CBAM, with this part of the greenhouse gas pricing of the European Union that is tackling external actors outside of our borders, with this regulation, we already started exporting our definitions, and it's very likely that others will take over. So there is some momentum which also will streamline the methodology.
Would expect that, yeah.
I would have many more questions on this methodology topic, but I would like now to jump to some maybe more practical issues and less theory. So what we see is that in the industry, the most widely used tool for LCA, life cycle assessment calculations, is still Microsoft Excel. Would you agree, or actually is it different? And would you say also that making it in Excel is a problem? Or I know from the banking field, sometimes they treat important calculations that are done in Excel as a systematic risk for failure in their company. Something similar in the sustainability area, if too much is in Excel?
Maybe regarding your first question, whether it's used or not, or mainly used or not, I would say it depends a lot. So I would say like the big companies, they mainly make use of existing software solutions, in best case already somehow being connected to, for example, a bill of materials, so to other ERP systems, or at least starting connecting that and building up maybe individual solutions. So here I would say it's no more Excel-based, but this mainly due to such a big product portfolio that with Excel sheets, it probably would get too complicated, and we would come to exactly that, what you said from the banking area. The defaults in the assessments would probably increase.
Yeah.
Nevertheless, Excel can be a good solution, especially for starting such a system, setting it up for, let's say, smaller companies, just because software solutions are quite expensive, to be honest. And then this is a good way to begin somewhere. But as soon as your product portfolio increases, or let's say the assessments you have to do will increase, Excel might get a bit difficult. I think one can build up a really good product carbon footprint assessment in Excel. It's just a multiplication, so it's not really rocket science. And you can also include database values in an Excel sheet. Also, that is no issue. But it might be easier to have additional faults into the system just by missing connections of cells. It is not so easy to understand, for example, a process flow chart, which can be built in different software solutions. So it's like the visibility is easy to understand and to get. And it's also maybe easier and faster to change aspects in that flow chart, which is harder to get in Excel.
Right.
But it is for sure being used, and it definitely could be a very good basis
in
the long run.
Right? And
exactly.
In the long run, rather take a professional tool that is tailored for
could be easier. Yeah.
Yes. Yes.
Yeah.
You mentioned getting in the bill of material.
Mm-hmm.
Well, I mean, this is obviously the dream of everyone, having some piece of software that I just push in the bill of material and it spits out the product carbon footprint, ideally already with a verified according to the ISO norm label.
Yeah.
I mean, how far away are we from that? And I understood that there is also some research going on in your research group on that.
Yeah, I think we are already there. At least, I mean, I don't know how good it is, but there are, I would say, a bunch of startups out there working on that, and also universities. So from different areas, there's work being paid on that. How good these solutions are, I don't know, because I didn't test them, but at least there is a lot ongoing. And I also hope that sooner than later there will be a good solution, or maybe even more good solutions to being used and being connected and integrated into existing software and company structures. In research, there's also a lot ongoing, and what we did until now is working with so-called large language models. Which brings me back again to that data selection part. So if you know our process, and we were at the point when we talked about somebody is purchasing materials, we know the entire process which happens at our company, then we are able to also build that into emission systems. And with that, we understand that value chain. And then it comes to the selection of which values of carbon emissions do we put behind that to get the PCF. And that connect from the real process into emission data could be simplified and maybe also being less subjective when making use of AI, large language models, however we name that. So there is ongoing research, ongoing practice, and maybe the startups are even faster than we are. Could be. On the other hand, maybe research has more deep dives into it. And I think the connect out of both worlds probably brings the best solution. So, but I think that sooner than later, there will be good solutions which solve that issue of having a bill of material directly being translated into a carbon footprint.
So you are using AI here at your chair in research efforts, if I summarize that correctly, to match information in the bill of material or in other documents with databases.
Yeah.
And for me, it was very interesting that you used the word objective. So would you say that if a human person is doing that matching, they would not be so good or inefficient compared with an automated large language model? So, like, is the main target of this research to just increase the efficiency, or you actually think an LLM model is also less prone to certain biases that the human mapper would have?
Yeah, it's both, I would say.
Interesting.
Definitely. So I think I need to be a bit careful with the definition. So I think it's more machine learning than really AI, what we do. So it's more language training.
Yes.
But on the one hand, the system is faster than if a person has to go through, for example, a long bill of material, especially, for example, if you think of steel production and we take it, for example, cradle to gate. So from resource extraction until the steel coil is ready, it's a huge process. And if you have to consider all the individual raw materials, energy streams, transport, and so on and so forth, it takes a while until you have that, let's say, huge bill of material, or in plural, bills of materials, built into, for example, a software solution to end up in a carbon footprint. If a large language model could already start connecting the real resources to a database, it is faster on the one hand, and it might be more objective than a person doing that. Because if we, for example, would all use that same large language model, then the subjectivity of individuals doing that assessment is gone. Nevertheless, it always needs an expert checking through whether that data selected by a model is really answering the questions we had. So is it really that material, really that energy which is existing in reality? And is it really reflecting the processes I'm doing?
You say that now, but maybe in 5 years the AI is better than
hopefully.
the human being. Okay, I see. But do you also see other fields of application for artificial intelligence or whatever it is, LLMs, machine learning, in the field of sustainability?
Yeah, I think which would be quite interesting is like optimization or forecasting. So often now when we do an LCA, it's status quo. And then we assess what is already there. But for example, as I said already previously, when we talk about sustainable designs, new products, new technologies, it might be quite interesting to come up with a bunch of scenarios. Sometimes we do it now, for example, to see what would happen if we change a parameter. Is it then getting better or worse than the status quo? But it's not really a prediction of future scenarios. And for that, I think it might be quite interesting to get optimization and also forecasting into AI models, which I'm really not an expert of, but hopefully people in my group can support on that. With that showing, if we decide today to do this and that, then the following scenarios might happen in future, and that would result in the following product carbon footprints, having the following costs and also the social value chain. With that, you're able to decide for your optimal solution, which probably will never ever be an optimal solution for all three pillars.
Right. Okay. But optimization between different KPIs of sustainability.
Yeah, and also coming up with a variety of scenarios, which might be quite time intensive if a person has to do it.
And you said you're not an expert on AI, but still you use it. Your expertise is in the methodological topics. But if we talked a bit before the podcast where you said you are now getting a computer scientist into your research team.
Yeah.
So even if it's not your expertise, you still bring in the topic proactively, have the expertise within your students, within your researchers, and you are investing also into the applications of AI here. Speaking about students, so you are launching a new industrial sustainability module in the master's program, so in the current semester, correct?
Yeah.
So that's the lecture you're giving, but it's a new one. It did not exist before.
No.
And what should the next generation of engineers, for example, alumni of the RWTH Aachen, be able to do that the current generation of engineers that are now in work life never were taught?
I would say integrating all three pillars of sustainability.
Environmental,
economic, and social.
Yes.
Yeah. And then also understanding the trade-offs between the three, maybe adding a technical perspective as a fourth one. So that also, for example, a long lifetime, good quality and things like that would also be integrated. So thinking always out of at least the 3 dimensions when it comes to processes, new product and things like that. And then on the other hand, vice versa, critical question the values being published.
Right.
Which I already said. So that's definitely one, maybe the most important goal I have for my students, that they are able to really critically think about values being published, really critically think about what means sustainability, and then also challenge numbers, but also the different dimensions. So why did somebody decide to take, for example, a product which has low emissions, but, for example, high costs and not the best social value chain? Question that. Is it the best option? And if so, why? Or why did somebody to choose that? Or might another option with high emissions and low costs be better because whatever? So that's critical thinking and reflection of sustainability in general would be the aspect what the next generation always needs to consider in every processes, decision making, and so on.
And when your current students in 10 years are in important positions in the industry and they are the decision takers, what do you think needs to have changed until then in sustainability assessment in your sphere of expertise, so that numbers are finally comparable in a good way and are really decision relevant?
Yeah, the key word is standardization. I would say.
Standardization, yes.
Yeah, especially in the industrial and application perspective. For research, we might have a different opinion, but for industry and comparison reasons, it's standardization. We just talked about assessing a product carbon footprint. There are variables where it can change, and why, for example, has a sequence different product carbon footprints? Where is that coming from? These variables, it might make sense to fix so that comparison increases, and with that we have a standardization, in best case cross-sectoral, and with that we also get a comparison of values, be it the carbon footprint but also other values, which makes a value chain easier to understand, and also products and processes way more comparable, which again also pays into, for example, technical expertise, improved processes, and so on.
To conclude our podcast, I will have a rapid fire section now for you. 3 questions, very quick answers, just 1 or 2 sentences. Let's get it started. Jana, 1 regulation you would simplify right tomorrow?
Standardization for product carbon footprint.
Yes. What do you think is the most underestimated data error in sustainability accounting?
Primary data from companies, which are, of course, not open access.
And what is the first thing that a CFO, a chief financial officer in a manufacturing company, should do this week to take emission costs seriously?
Yeah, implement it in every accounting you have internally for every forecasting.
Thanks a lot, Professor Dr. Jana Backes, Junior Professor for Safety, Security and Sustainability Evaluations and in Foresight Research here at RWTH Aachen. Thanks a lot for a great conversation.
Thank you as well.